Now we have the chapter 2, that is polynomials. You have already learned about polynomials in class 9. What is a polynomial? What is the zero of a polynomial? Remainder theorem, factor theorem, and so many things. Here you are going to learn some more things here. So already you know what is the zero of a polynomial. So let me consider a polynomial p of x such that it gives a value 0 when x is equal to k, or p of k is equal to 0 then k is the zero of that polynomial, zero of p of x. Okay, this is what the meaning of a zero of a polynomial. You have already learned this in class 9, so I'm just repeating that here. That is what is required here also. So p of x is equal to 0 when x is equal to k, or I can tell that p of k is equal to 0. These two lines mean the same, I think. Yeah. Then k is called as the zero of the polynomial p of x. So every polynomial can be divided into so many types. So the polynomial, based on the degree, it can be divided into so many. The first one is linear. The second one is quadratic. The third one is cubic. And so on. You have so many things. So thus we are only dealing with the first two mainly. Third one is a little bit, you can only know that. So you understood what is the meaning of the zero of a polynomial. So now we are going to have it with the different types of polynomials, that is linear, quadratic. You are going to find how do you find the zero of that. So now you have the linear one, linear polynomial, say p of x. So linear polynomial has a maximum degree of 1. So it should have some x term, and say it has some constant here. So let me take the coefficient of this x term to be a and the constant term as b here. So this becomes a general linear polynomial where a and b are real numbers, right? A and b are real numbers. So how do you find the zero of such a polynomial? So you need to find the value of x for which p of x is equal to 0. You know that p of x is ax plus b. So ax plus b should be equal to 0, or ax is equal to minus b. X is equal to minus b by a. This is the zero of the given polynomial, zero of p of x. Okay. So now we'll have this simple example based on what is given here. So I'm just going to use this directly instead of doing that. So now we have a polynomial p of x is equal to 4x plus 22. Okay, you need to find some value of x for which it becomes, the whole p of x becomes 0, or 4x plus 22 is equal to 0. So when I take 22 to the other side, it becomes 4x is equal to minus 22, x is equal to minus 11 by 2, because I can cancel out 2 here. This becomes 11. Minus 11 divided by 2. X becomes minus 11 by 2. Or it is minus b by a. This is a, this is b. Minus 22 divided by 4 gives the same value, right? That's what you understood just now. Okay, now we are going to have the quadratic equation, quadratic polynomial. So if you have a quadratic polynomial, it should be having of the form, so it should have a maximum power of 2. That is, there is some x square term. Okay, this is a polynomial with some x square term. Say it has one more x term and some constant term. So let me name them as a, b and c here. These two are the coefficients and this is a constant term. So we are going to learn how to find the zero of this in the next part of this. So just we are going to do this much itself. So there is a cubic polynomial, right? Cubic polynomial. Cubic polynomial will be of the form p of x is equal to ax cube plus bx square plus cx plus d. Because it should have an x cube term and other terms are optional, because this can be 0 but a cannot be equal to 0. That is the condition for all of them, because the first term should not be equal to 0, otherwise it cannot be a quadratic or cubic or in every case, right? So if I remove this, this becomes a quadratic. it doesn't remain a cubic polynomial. That's why a should not be equal to 0 and all the coefficients, all those terms should be real numbers. That's it, right? So now we are going to learn how to geometrically represent the zeros of the polynomial, right? So we are just going to learn a little bit more about what is the zero of a polynomial with the help of geometrical representation. Geometrical representation of zeros of the polynomial. So I can just tell that what is the zero of a polynomial is the one. Say let me have a y-axis and x-axis. So for a quadratic polynomial, that is in terms of x. So the number of times it touches the x-axis. Say you will have any curve for a polynomial. So number of time it may touch the x-axis gives the number of zeros. So if I have this as some random graph here, so it should have 3 zeros here because it is touching 3 times to the x-axis. That's the simple meaning of what is how to represent the zeros of a polynomial with the help of a graph. So now we are going to have a linear polynomial. Let me have that p of x is equal to 4x plus 4. So generally for having the linear polynomial, this is simple, you know already. I think in last year you have learned how to draw a line in a graph if you are given the equation. So let me take p of x to be equal to y. So this becomes y is equal to 4x plus 4. Okay, you need to find x and y. There are the coordinates you need to find. So you need to find 3 lines, 3 points to form the line over there. So you have a Cartesian plane. This is 0. This is the x-axis. This is the y-axis. Okay. Let me take x to be 0 in the first one so that it is easy for me to just search in one of the y-axis and just part the point that. Otherwise, I get confused where it is, right? So when x is equal to 0, this x term is going. So only 4 is remaining over there, right? This x term vanishes. Only 4 is there. So here you get 4. Okay. Now I'll take y to be 0. That means 4x plus 4 is 0. 4x plus 4 is 0. Or 4x is equal to minus 4. 4 and 4 again cancel. This becomes 1. So x is equal to minus 1. Minus 1. Next now I'm going to take some random number. Say I'll take 1. When I take 1, this becomes 4 into 1, that is 4, plus 4, that is 8. 8. So based on these numbers, I have to take some scale, right? I need to take some scale. I need to write that scale now. The scale comes to be in the x-axis. It is 1 unit enough. 1 unit itself. Y-axis, I'm going to take it 4 units because it's all the multiples of 4, right? It's easy for me to plot it such that it comes to be 4 only. So 4 units per 1 unit. 1 unit per 1 unit. Okay. This is a rough graph. Okay. X is 0, 1, minus 1. Here in the y-axis you need 4 and 8 enough, I think. So we'll take 4 to be here and 8 negative. I'll just mark 1 and keep. Okay, this becomes minus 2 and this is 2. Okay, I need to just plot the point now. This is 0, 4. So I need to start from 0 and jump 4 steps. That comes to be this point. That is 0, 4. Okay, now we have minus 1, 0. That is minus 1 and jump 0 steps upwards. So it is here itself. That is minus 1, 0. Now we have 1, 8. So 1 and 8 steps upward, it comes here. So just you can observe that it comes in line, that is they are collinear, right? So just go on joining them and write the equation, that is y is equal to 4x plus 4. This is the required equation This is just a general one example I have taken. From this you can understand that you have only one 0 for the given polynomial, which is that 0. That 0 comes to be at -1. Right? The y value comes to be 0 when x is -1. Therefore, -1 is the 0 of this polynomial. -1 is the 0 of p of x. P of x given here, this one, 4x plus 4. Right? That means it has only one 0 here, because this is a line that goes on touching the x-axis only at this point. Okay. Now we are going to have a quadratic polynomial. So say a p of x, quadratic polynomial. Yes, we'll have a quadratic polynomial that is x square minus 3x, x square minus 3x minus 4. Okay, so this looks like a complex graph, right? Because there is an x square term. If it was a linear term, x square was not there. We however understood that it was a linear graph because we had already learned last year about plotting the line and all. Okay, now we need to just find x and y. Y is equal to x square minus 3x minus 4. I think you know this. I'm not going to write that again here. Okay, so this x and y. This is equal to y. So we need to get a number of points because it's not going to be a simple graph. So let me start with -2, -1, 0, 1, 2, 3, 4, 5. Okay, enough. This many are enough to plot the graph because I want only the ones that are coming near 0. Okay, so now we are going on substituting the value of x in place of this whole term, right? So first when I substitute x, it becomes -2 whole square minus 3 into -2 minus 4. -2 whole square is 4. -3 into -2 becomes 6. So 4 plus 6 minus 4. 4 and -4 is going to be cancelled. This comes to be 6. Now we are going to substitute -1. -1 whole square minus 3 into -1. X is -1. X is -1. I'm going to substitute here. That's enough. So -1 whole square is 1. -3 into -1 comes to be +3 minus 4. 1 plus 3 is 4. 4 minus 4 is 0. This comes to be 0 here. Okay. Now we're going to substitute 0. The easy way to substitute 0 is just remove all the x terms and just put on the constant term. So this comes to be -4. Only the constant term. Okay. Now we are substituting 1. Directly just add the coefficients. Easy way to just add the coefficients. Here the coefficient is 1. Here it is -3. Here it is -4. So this comes to be 1 minus 3. That is -2. -2 minus 4 is -6. -6 at 1. So now you have one more. 2 you need to substitute now. So you don't have other option. Again you need to substitute and do. So in place of x I'm just substituting 2 here. So this comes to be 4. 3 into 2 is 6 minus 6 minus 4. 4 and -4 is get cancelled. You're getting -6 again. Right? I think this graph is returning back. Now it's substituting 3 now. That becomes 3 whole square minus 3 into 3 minus 4. This is 3 square is 3 into 3. This is also 3 into 3. So just cancel it off. You get -4. See here, you're getting a cyclical change. So now you have to substitute 4 here. 4 is 4 square minus 3 into 4 minus 4. That is 16 minus 12 minus 4. 12 plus 4 comes to be 16. 16 minus 16 is 0. Okay. Let me wrap this part. Now we need to substitute 5 now. What comes here? 5 square minus 3 into 5 minus 4. That is 25 minus 15 minus 4. 25 minus 15 is 10. 10 minus 4 is 6. See, 6 0 minus 4 minus 6. Minus 6 minus 4 is 0, 6. This comes back a mirror image. Okay. Now we are going to plot the graph. using so many points. So I need to take 1 unit itself here, right? Or shall I take 2 units? Here this number is divisible by 2, I think. So better I'll take 2 units along the y-axis and only 1 unit along the x-axis. So I don't need much of the negative x-axis, right? So let me go a little bit to the left hand side. This is -2, -1, 0, 1, 2, 3, 4, 5. Here I'll take 2 units, 2, 4, 6. This is -2, -4 and so on. You have here -6 and -8. I think only -6 is enough here. I am taking 2 units along the y-axis and 1 unit along the x-axis. I didn't write the scale here. I think you understand that much. This is -2 and 6. So it is -2 and 6 steps upwards. It comes here. -2, 6. -1, 0. That is on the x-axis itself. -1, 0. Okay, I need not write, I think. Again, otherwise it'll take a lot of space for just writing the coordinates. 0, -4. 0, -4 is this point. I'll just mark it big. 1, -6. 1, -6. Then 2, -6 again. Next you have 3 and -4. 3 and -4. Then you have 4 and 0. 4 and 0 steps upwards. This is 5 and 6 steps. 5 and 6 steps upward. Okay. This is 5, 6. Okay, we have plotted all the graphs. So the graph should be coming like this. So you find that here you have same points, right? At the same level. So I think it cannot be a straight line like this here. So it needs to be a curve. It needs to be a curve. And I'll go on continuing this. This comes to be, should be joining all this. Right, let me draw it more neatly. This comes to be like this. Yeah, this is the graph what you get. It's not so perfect also, but still it looks like this, right? Looks like a U. This type of graph is considered and it is called to be as a parabola. Parabola. This kind of a graph is symmetric along a given axis. Say this is an axis here. This is at 3/2. Whatever it is. I think that much is not required. So I can just tell that there is one line along which this is symmetric. That's why you got the symmetric numbers here. 6, 0, -4, -6, -6, -4, like that. You're going to get a symmetric. That's what. So this can be of two types, right? In this you got a graph like this. It can all be also a graph like this. Opposite of this. What does it depend on? So all of them are quadratic equations only. A quadratic polynomial. So how it can be different? So you have two cases now. Two cases. So how it can be like this or like this? It can be like this. If the first term you have a quadratic polynomial, that is ax square plus bx plus c. If a is greater than 0 or a is positive, then you'll get a graph like this. A is positive only, right? Then we'll get a graph like this. If you are getting graph like this, it means that a is less than 0, or you have a term like -x square or -2x square or -3x square, like that. That's what this is indicative of. So the number of zeros here can depend only upon the x-axis. I have already told during the linear polynomial, the number of times the graph touches the x-axis tells how many zeros are present for that given polynomial. So here you have a graph like this which touches at these 2 points. You have already found out that is -1 0 and 4 0 are the points at which this graph touches the x-axis. So those 2 points refer to the zeros of the given polynomial, that is x square minus 3x minus 4 have the zeros at -1 and 4, and hence they can be called as the zeros of those polynomial. So we are going to get a number of cases at which you can just tell whether it can have a graph which it can have how many zeros and all. So there can be different type of parabolas, right? So you have case 1 when the parabola comes to be like this, or it comes to be like this, right? In such cases you have 2 zeros, as we have just got in the graph that we have drawn. That comes to be 2 zeros. Next case, when you have a graph just like this, it just touches the x-axis at 1 point, or it can be in the negative direction also. It just touches it at 1 point, and such of them have only 1 0. The third case is when the graph comes to be like this. It never touches the x-axis, or it can be in the opposite direction also. It never touches the x-axis. This is the x-axis, right? This is the rough graph. In such case you have no zeros. That means there exists no value for x for which that polynomial or the algebraic expression becomes 0. That's why such polynomials have no zeros. Okay, there are some numbers like that. Okay, now we are going on to the cubic polynomial. Moving on to the graph of a cubic polynomial. As in the previous one we had a complex graph. It's a cubic, right? It's going to be more complex now. So I'll take a simpler one. Say p of x is equal to x cube minus 4x. This is a cubic polynomial because you have an x cube term, that's it. Other things are optional. Here I have taken one minus 4x. Okay, so you are asked to find the zeros of this by just plotting the graph. So let me take some points. Say this, I need to get the points, right? So x and y. So let me take from -2, -1, 0, 1 and 2. Okay, this many points I'll take. I need to find the values of y now. This is the y, right? This expression stands for y. So I need to just fill this table now. -2, that becomes -2 whole cube minus 4 into -2. -2 whole cube is 2 cube is 8. So -1 cube is -8. -2 cube is 8. -8. This is -4 into -2. Minus of minus is plus. Plus 8. This comes to be 0. Okay, you have 0 now here. Now we are going to substitute -1. -1 whole cube in place of x. You have -1. Then you have -4 into x in place of that -1. So this becomes -1 whole cube is -1. Minus of minus is plus. Plus 4. It comes to be 3. So this you get in 3 here. Okay. Next is a simple one. Substituting 0. 0. There are no constant terms. So this comes to be 0 only. Okay. Now we are substituting 1. 1 is just adding the coefficients, right? As in we were done in the previous one. Adding the coefficients. This is 1 and -4. 1 minus 4 is -3. Now we are going to substitute 2. So for substituting 2, in place of x, I need to write 2. So this is 2 cube minus 4 into 2. That is 8 minus 8. That is again 0. So many zeros we got here itself. If you are plotting the graph, you can tell so many zeros are there. So let me draw the graph here to just represent that in the graphical format. In the y-axis, I need only 3, right? So let it be 1, 2, 3, -1, -2, -3, here -1, and minus 2. This much enough. This is the x-axis. This is the y-axis. You need to just write the scale also here. That is just 1 unit is 1 centimeter is 1 unit. So you have the points minus 2, 0. That is on the x-axis. So this comes to be minus 2, 0. Next you have minus 1, 3, minus 1 and 3 steps upwards. That comes to be here. Minus 1, 3. Next you have 0, 0. That is the origin. Next you have 1, minus 3. 1, minus 3. I'll just rub this part. Let it this side. 1, minus 3 comes here. Next you have 2, 0. 2, 0. This is the point. So I need to just join these points in that order itself. You can just go on joining here and there. You need to just join it in the order. So this is not going to be a straight line, however. So let me join this part first. This is just a rough one. So it is somewhat like this. This is the graph, somewhat you get. This is from which you can understand that there are 3 points at which it touches the x-axis at minus 2, 0 and 2. That means that this cubic polynomial has 3 zeros. So you can understand that number of times the curve or the given graph touches the x-axis gives the number of how many zeros the polynomial has.